Hello everyone. Today video will discuss about get R limit and set R limit functions. Here get R limit is nothing but get resource limits. Set R limit means setting the resource limits. The purpose of using these two functions is every process has a set of resource limits, some of which can be queried and changed by using get R limit and set R limit functions, which means that certain values, we'll discuss shortly what kind of the limits are there, like the maximum number of child processes created by a particular process, that is the one limit. Yes, maximum number of files that can be opened by a particular process. Like that, we are having the different limitations for particular process. So with respect to that one, we wanted to retrieve and we wanted to set. So in that case, we are using these two APIs here. The first get R limit, it is having the resource. Just we can find it here. Struct R limit, nothing but it is pointing to the one structure. Here, the first argument is resource, that is the name of the resource. Second one, it is pointing to R limit structure where we are having the two fields. One is current limit and one more is maximum limit. Current limit is nothing but current existing value. Maximum limit is the overall value. It's just like I will give you one example here. You have a maximum marks is 625 and your scored marks is 550. Here 550 is the current limit and 625 is the maximum limit. Okay, so in that context we need to understand. And with respect to this one, we have three rules for resource limit. The first one, a process can change its soft limit to a value less than or equal to hard limit. That means currently the process is having the 550 value out of 625. Say for example, I can increase that value up to what extent? That is 625. I can't increase more than 625. Next, a process can lower its hard limit to a value greater than or equal to its soft limit. Again, this is the reverse one. We are having the currently value is 625. Okay. We can decrease that 625 value to up to what extent? Current soft limit value, that is nothing but 550. Okay. And one more point, the process can raise a hard limit. Which means, say for example, current 625 values, I wanted to set as a 725. Say for example. So it can be updated, but the thing is that only super user process can increase that value. So as I told, some of the resource names like R limit as R limit core, R limit CPU, R limit data, R limit f size, R limit logs. Okay, we'll see one by one. R limit as the maximum size in bytes of the process total available memory here. That means the total memory it can be used by a process, that is R limit as. Then R limit code, maximum size in bytes of the code file. Nothing but there is a temporary file is created with respect to that one. R limit CPU, the maximum CPU time in seconds that can be consumed or used by the process. R limit data, the maximum size in bytes of the data segment. I think already we discussed the data segment in memory layout of C program there. Okay. What is the maximum initialized data segment and what is the uninitialized data segment we can use it. R limit f size. So what is the maximum size of the file can be created in terms of bytes. R limit logs, there is a maximum number of logs a process can hold. I think already we discussed about this concept like read log and write log. Okay. So how many logs we can apply on that particular file by using the process. Next, maximum amount of memory in bytes that process can log into a memory using mlog. Nothing but in particular your memory location, what is the log we can apply. R limit no file, maximum number of open files. As I highlighted already this point, how many files can be opened by a particular process. So that is decided by R limit no file. Number of files. The maximum number of child process per real user. Nothing but again The maximum child process we can create it by a particular process by calling the fork API that is decided by R limit NP process. R limit RSS, that is the resident set size. Usually this concept we are using in memory level of the C program only. Next, R limit SB size, maximum size in bytes of the socket buffer. Again it is with respect to the memory level. And the stack, it is also related to the memory level. Only thing is that these limits is deciding the maximum value and current values. So next one, kernel support for process. The data structure and execution of the processes are dependent on operating system implementations. The process consists of mainly a text segment, data segment, and stack segment. A segment is an area of memory that is managed by the system as a unit. Means how exactly a particular process is holding a data structure. I hope you got the term. Data structure is nothing but it is a storage things and along with some of the files. Okay? And text segment consists of the program text and machine instruction. Already I told this one. Executive instructions are stored in the text segment. And data segment is nothing but again it is having the initialized data segment and uninitialized data segment. Stack segment, again it is a runtime variables are stored and return addresses of all the functions are stored. Okay. Unix kernel has a process table that keeps the track of all active process present in the system. That means currently how many processes are executing in the system, that is always registered in one table. That table what I can call as a process table. And sometimes what happens in that process table, we are having a system processes as well as user defined process. Every entry in the process table contains a pointer to text, data, and stack segment, and also view area of the process. The view area is nothing but how many files are opened by a particular process. That is a one part. And what is the file descriptor value held by that process. All the things is stored in the view process. I think I have given the point. View area of a process is an extension of process table entry and contains the other process specific data such as file descriptor table, parent root directory, working directory, inode numbers, and set of system imposed process limits. Nothing but just now what I discussed about the resource limits. Okay. This is about the simple data structure what we are using for the kernel support for process. Just you can get it the point what I am highlighting here. This is the process table. This is the one entry. Mean the process which is the current active process that is pointing to per process reason table. Nothing but this is the process area here. Just we can find it. With respect to per reason table is nothing but there is an indexing with respect to the memory layout of the program. Nothing but here we are pointing to the all the segments. Just we can find it here. Text segment, data segment, and stack segment. But how we are not directly fetching this one. It is through kernel reason table. We need to. It is a part of the space provided by the kernel here. And this is the U area. It contains the file descriptor table, current directory, root directory. Okay. About the particular process. So this is the entire concept what I can call as a Unix process data structure. The one point I need to remember. Whenever the process is running, it is having the entry in one table. That table is process table. That you keep in mind. All the processes in the Unix system except the process that is created by the system root are created by the fork system. Nothing but, as I already told, maximum processes in the system are created by calling the one API that is a fork. You might be heard that fork is nothing but creating the child processes here. Okay. And once we created the child process, there onwards, both child and parent process are executing by sharing the data here. That is one concept. We'll discuss shortly how they are sharing the data here. Just we can find it in the diagram. It is more clear. Just here, process table. Just we can find it. Parent and child. Both are created independently. There is a process area, but the file table what we can find it is shared by both parent and as well as child. And also we can find it the stack, data segment, stack segment. Again, it is also shared by the parent and child process. Okay. The one point is that whenever a parent is creating the child process, all the data structure of the parent is inheriting to the child process. We'll see that there is some attributes are inherited from parent to child. So these are the attribute. Real user identification number, nothing but who created the parent process is assigned the one ID, that is what I can call as R user ID, and then R group identification number, nothing but every user is belonging to the one group, so that ID here. An effective user identification number, nothing but every process has the access permission or privileges, that ID what I can call as an effective user ID. An effective group identification number, again it is a privilege with respect to the group here. Saved set user ID and saved set group ID, nothing but these are the effective user ID and effective group ID values, but this is only saved when the process start executing. Process group identification number and session group identification number, nothing but every process is belong to one group, that ID what I can call as a process group, and every process is belong to one session, that ID what I can call as a session identification number. Next, supplementary group identification numbers, which means every process is it having multiple groups? Is it belong to more than one group? In that case, supplementary group identification numbers are working here. Next, current directory. I think already I discussed many times. Current directory means what? Uh, Working directory of that process, what I can call as a current directory. Root directory is nothing but complete path name where the currently this process is located. That is what I can call as a root directory here. And signal handling means currently what are the signals a process can respond, what are the signals can be blocked by a process, that is what I can call as a signal handling settings. Signal mask, a signal mask that specifies which signals are to be blocked, that's what the point I highlighted. If suppose some of the signals cannot be handled, in that case it will be blocked. And unmask, a file mode mask that is used to creation of the files, nothing but it is the access permission related, like read, write, execute permission. By default we are having the one value, so in that value we are ORing with this umask value actually. So whatever the resultant value we are getting, that will become the final access permissions here. Next, nice value. It is usually applicable when the process is with respect to the process scheduling, nothing but you might be heard the term like process scheduling. In that case, we are setting the priority. That is what I can call as a process scheduling priority. Next, controlling terminal. So the controlling terminal of the process is nothing but usually it is related to the device files. Okay. So when one file, if I use it as a device file, shall I use that device file itself is a controlling terminal or not? That we need to decide. So those are the attributes which are inherited from parent to child process. Now, in addition to the above attributes, the following attributes are different between parent and child process. There is nothing but process identification number, parent process identification number, pending signals, alarm clock time, and file logs. Here, process identification number is nothing but every process is identified uniquely, so that ID what I can call as the PID of the process. Parent process identification number is nothing but if suppose A is a one process, it is created the child as a P here. Now B child parent is A, but A parent is different. So every process is having its own parent process ID. That ID what I can call as a parent process ID. Pending signals are nothing but some of the signals are not delivered to the process. Those signals are what I can call as a pending signals. Alarm clock time is nothing but, so it is a time set by the parent process, that is a concept. then file logs are nothing but read and write.